Good morning, students. Welcome to your physics class. I hope you are doing good and are in good health. So, let's start with our class.
In our today's class, we are going to start a new chapter, that is chapter number 11, Work and Energy. In our today's class, we will see the concept of work in detail. We will see the scientific conception of work done by a constant force. Okay? In our daily life, this term called work is very loosely defined. For example, me recording this video right now. But in physics, we want precise definition. So in this video, we will see how do we define work in physics. So, according to physics, work done on an object is equal to force applied on that object multiplied by displacement of that object. This means that if you want to do work, first you need to push or pull on it because you need to provide a force, and while pushing or pulling on it, you have to make it move. That's the condition to do work in physics. So you have to push on an object because if you don't push or pull, force will be zero and work will be zero, right? And while pushing, you have to make it move because if you don't make it move, there will be no displacement and again work will be zero. So let's quickly look at some example to make more sense of it. Imagine someone is pushing a grocery cart on grass. Do you think that person is doing work on that cart? Let's see. She is pushing that cart, so she is moving and she is providing a force on it. Notice while pushing it, she is making that cart move. So she is putting a force and is displacing the cart. Therefore, she is doing work on that cart. On the other hand, what if a person is trying to push a wall? Do you think he is doing work? Well, let's see. Again, since he is pushing on that wall, he is putting a force on it, right? But that wall is not moving anywhere, just staying there. So he is not making that wall move. So he is putting a force, but he is not making it move. So he does not do any work here, right? So now he might say that he had got tired by pushing that wall for 3 hours. Doesn't matter. He didn't make it move, didn't displace it. So therefore, no work is being done. Okay. Now let's take another example. Let's go to the outer space where there is no gravity, no friction, so that we can keep things simple. Imagine we have an astronaut with ball in his hand. Say he throws that ball. Do you think that he did work? Think about this for a while. Alright, let's look at it. When the astronaut throws the ball, he is clearly pushing that ball, right, to make that throw. While he is pushing that ball, notice that he is displacing that ball. He is making that ball move while pushing it, and therefore he provided force and did displacement. Therefore, he did work on that ball. But what happens once the ball gets thrown? Do you think now he is doing work on that ball? Think about this. Once that ball is released, notice that he is no longer pushing it. So yes, the ball is moving. That is, the ball is getting displaced. But now nobody is pushing on it, right? And now no longer work is being done on that ball. Therefore, no force acting on that ball. Remember, we have to push it. While pushing it, make it move. So the astronaut only did work when the ball was in his hands. The moment the ball started moving away from his hands, no longer work is being done by the astronaut. Okay? So students, let's revise what we have learned so far. We have learned about the work done by a constant force. Remember students, we have learned for a constant force how can we calculate the work done. Okay. Now work done will be represented by capital W. Okay. So work done W is equal to the F into S. Okay, capital F is the representation of force and small s is the representation of the displacement. Okay, so work done is equal to the product of the magnitude of applied force and the displacement traveled by the body. Okay. Now let's see few important points about the work done. Okay, so work done is a scalar quantity. It has just the magnitude and it has no direction. Okay, now another thing is work done depends on two factors. What are they? As we know, it is the product of force and displacement, right? So the first factor is the magnitude of the applied force F, and the second factor is the distance traveled by the body in the direction of the applied force, that is S. Okay. The minimum amount of work that you can do is 0, right? If you can just lie around doing nothing, you do 0 work. That's the least you can do, right? But in physics, you can even do less work than 0. Let's find it out how. We know how to calculate work, right? It is the force applied on an object multiplied with the displacement of that object. This means that to do work, we need to push or pull on something. And while pushing or pulling, we have to make it move. This is how we do work. Now here is the thing. This work done can be positive, 0 and negative. So let's quickly find out when it is positive and when it is negative. Now if the force and displacement happen to be in the same direction, that's when we say that the work done is positive. On the other hand, if the force and displacement happen to be in the opposite direction, we will see in some examples, we say that work done is negative. This is when the work becomes smaller than 0 because it's a negative number. So let's look at some examples. Suppose a lady is pushing a grocery cart and makes it move. Now she is doing work on it because she is pushing on it and she is making it move, right? Now, is that work positive or negative? Well, let's see. If you will look at the direction of the force, she is pushing it towards the rightward direction, and looking what direction that cart is moving, it is also moving in the same direction to the right itself. So here is the force and the displacement are in the same direction. Therefore, here she is doing positive work on that cart. The work is positive here. On the other hand, imagine an uncontrollable car is being pushed by a Superman. Let's think of the work done by the Superman on the car. Let's say if it is negative or positive. Let's look at one more time. So here is the Superman and here is the uncontrollable car. The moment the Superman starts pushing on it to stop it, he pushes a force on it, right? What direction this Superman is pushing this car? He is pushing towards the right, okay? But in what direction is the car moving? Now the car is moving to the left as it is being stopped, noticed? Right? The car is moving towards the left. Notice that the force is towards the right, but its displacement is towards the left. This shows that the force and displacement are in the opposite direction. So over here the Superman did the negative work on the car. Okay. So here work done is negative.